In our final example, we're going to do a two-dimensional projectile problem where we throw a pebble at 30 degrees and we want to know what's the highest point it reaches, how long is it airborne, and then how far from the cliff does it splash down. Again, what we want to do is we want to divide our problem into sections because we've got an upward section and a downward section. And this time we want to look at how would you work with a problem that you want to divide in sections, combine your results. Also, we've got some horizontal motion and some vertical motion. So we've got to do a vertical list and a horizontal list. I'm going to come all the way to the right and make my X list. Because as I think ahead, the questions do kind of guide me. I'm going to be dealing with my horizontal distance as the final part of the problem. You always use the time, if you need to get time, you want to work with the vertical portion of the problem unless you have everything you need in the X. Delta X is what we ultimately want to find in part C of the question. Initial velocity. Now, we've got an angle, so we've got to do components. So this is going to be 20 times the cosine of 30, which happens to be 17.3 meters per second. I'm going to keep some extra decimal places there so I can round off in the end and not carry some round off error through my problem. Now, because we're at constant speed, my final velocity in the x direction, 17.3. Acceleration horizontally is 0. Time, I don't know how long it's going to take me to get from the edge of the cliff to out to the water here, so that's unknown. If I can find the time in the y directions, what I can do is use that time to find how far from the cliff. We want to use a similar strategy to the last problem to find our y top. So let's make a y top list. Delta y equals question mark. V naught is going to be 20. See, the vertical component is opposite of that 30-degree angle, so we're going to use a sine. Sine 30 is going to be 10 meters per second. Because we're setting this list of givens up for the top of the arc, we know that our vertical VF is going to be 0, acceleration negative 10, time question mark. What we want to do here is, just like the last equation, last problem, to get the total height, and since we need the total time, we'll do this a little bit differently just to show variation. There's more than one possible way. We could say that VF equals V naught plus acceleration times time, so that's going to be 0 equals 10 minus 10t, or you could say plus negative 10t. Just by examination, you can tell that t is going to be equal to 1 second. Then, if I say delta y, and I'll put top here again, just to remind myself this is just the distance to the top of the arc. Delta y to the top of the arc is going to be 10 times 1 plus 1/2 times negative 10 times 1 squared. Using the first equation, initial velocity times time plus 1/2 at squared. So delta y is going to equal 5 meters. Now again, that's the height from our cliff, and we're neglecting any difference between a person's hand and the height of the cliff here. So from here to here is 5 meters. Now the rest of the way down, remember, is 54. So if we want to make a I'll call this list Y2 because this is from the top of the arc to the ocean. Delta Y is going to equal negative 59 meters. That's a downward delta Y. V naught is going to be equal to 0. This section starts at the top of the arc. The vertical velocity is 0 here. VF, we don't know how fast it's going when it hits the water. A is going to be negative 10. Time, we're not quite sure of. What we can do here is treat this like we're just dropping it off of a higher cliff, because we start with 0 vertical velocity. It's just like the dropping problem. So what we'll do is we'll say that delta Y equals V naught Y plus times time 1/2 AT squared. This part goes to 0. And so we say negative 59 equals 1/2 times negative 10 times time squared. So what we're going to have to wind up doing here is dividing negative 59 by negative 5. So we get 11.8 equals T squared. And so that's going to mean T equals 3.4 seconds. Now, let's make sure we understand what that 3.4 seconds applies to. Remember, we were doing Y2 for this list. So that's going to be from the top to splashdown is 3.4 seconds. In the previous section, from throwing to the top of the arc is 1 second. So that means the total time is 4.4 seconds. And that's going to go into our X list, because during that entire 4.4 seconds, we've got some horizontal motion. Since A equals 0, we can cross out that whole second term, and our equation gets really easy really quick. 17.3 times 4.4 . And again, I'm keeping some extra digits in my calculator, and I'll round off at the very end here. So there's my 4.4 seconds multiplied times 17.3. And I'll round off now in the very end. Delta X is going to equal 77 meters. So in this problem, again, it's always important to make sure you know how your answers fit into the picture. Notice I'm writing all over my diagram here. You should always use a diagram, and that way you can know what your givens apply to, what your answers apply to. You'll get a correct answer at the end of the problem.